Now, at this point, we want to discuss again bodies, what are components, what are assemblies. All these things make up your design. In this section, we will use some of these things we have done, some of the things we have actually produced to explain what are bodies and what are components and what are assemblies and how they relate. We are now in the theory of the design. There is no use cramming the definition of bodies and components. I mean, somebody is saying you define bodies. Bodies are blah, 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 blah. Forget about that. Even though the clarity we have given you here is necessary to enable development of skills in maximizing their power for engineering design, for optimization, for prototyping, and for manufacturing. Those are the things we are after. It will be useful for orchestrating collaborative work. Basic skills are needed before we delve too deeply into theory. Otherwise, you are just cramming, and it is useless, completely useless. You will not be asked too many theory questions. You may not even be asked any theory question in this course. Instead, you are to use your skills to demonstrate mastery of theory. So when you know the theory, then you should possess skills that can be used to demonstrate it. That is what this course is all about. It's the skills that show that you have mastered the theory. So, but the theory now is the definition of components, bodies, and assemblies. And you will see that these things are properly defined. And you need to keep those definitions in mind for you to be able to use your skills, for you to be able to hone your skills and do good work. What is a body? What is a body? In our context, a body is the visual representation of your design. Mathematically, we say bodies are contiguous pieces of a three-dimensional Euclidean space occupied by materials and enclosed in surfaces. What you call surfaces in ordinary life, in Fusion 360, we call those one faces. So when Fusion 360 says faces, it means surfaces. A discontinuous body will be broken into a number of contiguous bodies. So a body must be a whole body without any space between them. So you can remember when we were doing our revolving, we revolved these two profiles. But because these two profiles are completely disjoint, they created not one body, but two bodies. Even though we told it to create a body, but it did not create a body, it created two bodies. And it is because of the fact that they are disjoint. Okay, so that is the thing. So a discontinuous body will be broken into a number of contiguous bodies. An example came in the revolution we had, the revolving we had when creating the crank. Recall that the revolving the profiles here on a single axis created two bodies. Remember that. What about component? Every design has a top-level component, and it is the default component. And that default component bears the name of your file. So that is your top-level component. So whenever you start to draw, whether you have anything else, a component is defined. This is the minimal component possible in a Fusion 360 design. Any other component, you can now create further components. Any other component you create is enclosed inside this component. So it's a component enclosing other components. So even the components you create can also enclose other components. There are also bodies. A component can enclose bodies, can enclose sketches, can enclose construction geometry, and many other things. All of them are contained inside a component. There are also bodies and other entities. A defined component may contain other components and bodies. A collection of bodies in a component is listed under the bodies in that component. So a component can consist of several bodies, but you will see that a component contains more than that. A component is the closest idealization of what you call part, a part of an assembly. But a component is a specific definition abstractly, and you need to bear that in mind when you are working with assemblies and designs in Fusion 360. Contained bodies, contained components. How do we decide to arrange our design? Should our components contain bodies, components, or a mix? Should they just contain components, or should they contain components and bodies? To answer this question, we need to see the distinction. There is no defined, here is the distinction between a body and a component. There are no defined relationships among bodies that are contained. So you can have several bodies. They just exist. Bodies just exist without any formal definition of how do they relate. What motions are possible between them? What is their interaction like? Nothing. They just bodies. They just exist as bodies, dead bodies. If on the other hand, we have contained components, the container component also includes definitions of the relationships between the contained components. This relationship helps to create assemblies that behave like real entities. It is the relationships that we create among components that make them behave realistic. So when we are creating relationships, the goal is to create reality, is to add realism to our bodies. So bodies cannot be made realistic, but components can. Components can. Now you will see how we will do that shortly. Joints, relative displacements, and motions. As we demonstrated previously, there are 6 possible relative displacements of motions between 2 related parts. 3 linear, 3 linear, and 3 rotational. You can look at it as X, Y, Z. Those are the 3 linear possibilities, and then rotating about those axes. Those are the only 6. Any other displacement can be related to those 6. So maximum of 6 degrees of freedom. Theoretically does not allow relationships between bodies. If there's need to create relationships, they will occur between components. So if you think a body needs a relationship, then make a component out of it. Then you are able to create relationships. The means for defining these relationships is the instrument called joint. Now, joint conjures something in your mind. You look at the elbow joint, and you look at your leg joint and knee joint and the ankle joint, all those things. The joint is all of that and much more. A joint is an abstraction. Okay, we are back into theory now. A joint is an abstraction that defines selective opening of some of the degrees of freedom after locking them up. A rigid joint, for example, reduces the 6 degrees of freedom to 0. Other joints open these degrees of freedom piecemeal. They open them up piecemeal. A sliding joint would open one particular direction of slide. So out of the 6, you have 6 degrees of freedom. A joint, first of all, turns them to 0 and then releases 1. A cylindrical joint can release 2. A revolute joint can release one revolution joint, and then a sliding joint release. So that depends on what type of joint. A rigid joint removes all your degrees of freedom. So that is what it is. In order to define these joints, you need what is called a joint origin. And that is something, once you understand the concept of joint origin, then you know everything you need to know about joints. Before we go on, we want to first of all do a demonstration of the easiest way to do a joint. If the mating joints or relating components are already at their final relative locations with each other, as-built joint provides an easy way to create the joint relationships. By the time you get to this point, there is if you click on this, it will take you to an Autodesk video, which gives you another view of joints. And I try to make sure that my notes and my demonstrations and my videos are not in any competition with the ones by the manufacturer. They are additive. They are not either or. It's not that you watch this or this. They are both. You watch all my own videos and you watch all their own videos. By the time you have put everything together, you should have a very good understanding of what you should do. So my videos are supposed to help you understand theirs, and I hope sometimes their videos helps you to understand mine, because they may mention things that I did not mention, or they are more specific and more succinct in the way they do their own. So just do both. I'm not going to click this. I will leave you to click this from your comfort of your homes So the joint has a point of reference. When you are in a joint dialogue, it is important to find a point of reference, also called the joint origin. The joint origin is not necessarily located on the material body of the component. It is usually on a face, that is on the surface, or a geometric entity related to the face, or an edge, or a geometric entity related to that edge. For instance, if you have a cylinder, the edge of the cylinder, it could be the center that produces that circle. And it may not even necessarily be part of that body, but that could be the joint origin that is important. Hovering your mouse button on edges and faces lights up all the possible joint origins for you to pick from. And to do this, it is only by practice. There is nothing you can crack that will make you able to do this. It's only by practicing this thing, try and error, and achieving some failures and some successes that will make you know what these things are. The student that doesn't practice these things will find himself flat-footed at the end of the term. But that's not even the punishment. The punishment is that you'll be broke and poor for when you are out of the university, where your mates are getting good jobs because they took something seriously. I don't think that the punishment you get is getting low grades. You can get high grades and still be poor. And so just make sure that you practice these things and you gain the skills that are necessary. In two relating components, the joint origin will be brought together in creating the joint. So when you select the joint origins, those are the things that will be brought together, and then there can be some rotations or flipping to now to make them permanent and create that degree of freedom that will be released out of the 6. Out of the 6, 1 or 2 degrees of freedom will be released. So every joint has 1 or 2 degrees of freedom out of the 6, no more than that. I'm not aware of any joint that, at least as far as my experience goes, that gives you more than 2 of the 6 degrees of freedom. So a joint can be looked at as something that reduces the degree of freedom, or it can also be looked at as something that, first of all, reduces all the degrees of freedom to 0 and gives you 2 out of them. So it depends on how you want to look at it. But that is the way Fusion 360 behaves. And if you are coming from other drawing environment like SolidWorks, the way they create their relationships is completely different. So, but this is one special thing about Fusion 360. This is the way Fusion 360 behaves. If you want to use SolidWorks or some other Solid Edge, then you have to learn the way their ability to relate different components work. Joint, point of reference continued. Have you your design ready and implement this as you try to understand them? Attempting at cramming this will not work. It can only be understood by doing. Now, what I'm going to do here is that I'm just going to take you through a situation where we have components. So we have components that have been defined. You have a crank, you have a connecting rod, you have a piston with a spin, and you have an end rotor. You have all of these things. You have all of these things there. Okay, so you have components that exist without defined relationships. So when we have a component like this, you can see this component, it has con rod as a component, the piston is a component, and the piston is showing you in a different sign that it also contains, it's not just a component, it's a component that contains more components. And then you have the crank, which is a component, and you have the end rotor, which is still a component. But after this point, no relationships have been defined. They are just components. So when you have components that have no relationships, they are as bad as bodies. They are just like bodies. So if you're just making a component out of a body doesn't change anything. It is still like a body. But it just gives you the opportunity of now defining relationship. But until you define those relationships, you are still as before. In this example, we have a set of components inside the default top component, piston with a plain subcomponent, connecting rod. The connecting rod can be further broken into con head, con body, and pins. We will do that later, but leave it now as a single unit for now. And then the rotor end piece. They no defined relationships. Creating the cylinder. Before we define relationships, it's convenient for us to first create a transparent cylinder. That cylinder cavity is the part of the engine block where the piston will be moving up and down. We just represent it now, right? With just a cylinder that is transparent. That is just to represent it. And we need that representation to do this demonstration. And we make it transparent to see the piston's motion inside it as we animate the design. We are also going to set some objects immovable. We are going to set some objects immovable while others will have restricted motions. For your information, we are going to make this cylinder immovable because this cylinder is actually representing the engine block, the part of the engine block that we are saying here. If we show the whole thing, you won't see anything. So we are just showing you something, but that cylinder with respect to these other things. The other thing that will not be movable is this end rotor. This end rotor will also be fixed. So every other thing will now move relative to them. So we are going to set some objects immovable while others will have restricted motions.